Welcome to lesson 73, making predictions with best fit lines. We're going to use those lines to predict what we think is going to happen in the rest of the context of the problem. Here's our first problem. The scatter plot shows the relationship of low and high temperatures last year. The next day, the low temperature is going to be 80 degrees, so we have to predict the high temperature for that day. So here's our problem. What is the approximate high temperature when the low is 80 degrees? And again, it's approximate because we're making our best guess based on this data. We have tons of facts that are just on this table, so rather than listing all of them, all I'm going to list is points in the graph, and they have a positive correlation. So here is our plan. We're going to create a best fit line using this data as best we can. Here's a challenge though. Notice we can't see the origin on this graph. We don't see 0.00. Our minimum values for y are 70 and for x is 50. So even if we draw a best fit line, when that line hits that y is not necessarily the y axis. So here's our plan for that. We're going to use two of the points from the line of best fit to calculate the slope. And then we're going to take one of the clear points on our graph and the slope to create an equation and solve for b. So we're going to plug in y, m, x to figure out what the plus b is. Once we have our b, we're going to write a new equation in y-intercept form, where we're going to try and figure out the y when the x is 80. So that's going to be our plan. It's multiple steps. Hit pause and jot it down. Okay, let's put our plan into action. We're going to create our line of best fit, LBF. Then we're going to identify our B and M so that we can create an equation. And then we're going to use our equation to approximate the high temperature. Okay, let's try this out. So here's one of the challenges we have here. We're just choosing 2 points. And we're going to try and go through as many of the points as possible. Let's say here and here. Okay, here we go. So we kind of have an approximation going, a line of best fit. Let's see if we can identify our B and our M. So the first challenge is we don't actually have a 0 here. This is where x equals 50. So I cannot say that this is our intercept. So that's a challenge in this graph over here. But let's see what we can do. Is there another way to identify B? Well, we can if we have our M. So let's use 2 points. I'm going to use this point here, which is 62, 82. And I'm going to use, how about, because remember I can use any 2 points in the line. How about this point here, which is 60 and 80. Okay, so we're going to use those 2 points to find our M. So y2 minus y1 over x2 minus x1. We have 82 minus 80 for our y's and 62 minus 60 for our x's. So we have 2 over 2. So our slope, m, is equal to 1. So that's a pretty strong positive correlation if it's almost straight and direct. This is pretty good. Let's actually try this out then. So we actually have this, y equals mx plus b. We know the m is equal to 1, but we don't know what the b is equal to. So let's use one of the points to find it. Okay, so we're going to use 60, 80. And I'm just going to substitute. So 80 is equal to 1 times 60 plus b. That's what I'm going to do. Is now I just want to have one variable, and using a point helps when I cannot see my y-intercept. So 80 is equal to 60 plus b minus 60 minus 60. So 20 is equal to b. Okay, that is really helpful for us. So now we have an equation. We have y is equal to 1x plus 20 with this equation. So there we go. We did that part. Now we have an equation. Now let's try and find, we want to know the temperature when the low is 80. So when the low temperature is 80, when x is equal to 80, we want to know what y is equal to. Okay, let's just substitute this in. I'm going to put y is equal to 1 times 80 plus 20. Y is equal to 80 plus 20. So my approximation, y is equal to 100 degrees Fahrenheit. There you have it, Math Marbles. Look at what we were able to do. We used our line of best fit to help us identify our, at least in this case, we can find our slope using 2 points. We couldn't find our y-intercept, so we were able to just use a point to find that. We found b. We created an equation, and then we use that equation to find the approximation of the high temperature when we have a low temperature. So let's write that final sentence down. Predict the high temperature for the day. We predict the high temperature of 100 degrees Fahrenheit when the low temp is 80 degrees. We use the line of best fit represented by the equation y equals x plus 20. And done. Hit pause so you can jot this down into your notes. Here's our second scatter plot question for today. Take 10 seconds to just read through it on your own. All right, so what are they asking? They want to know about how much water flows from the house after 38 minutes. That's the basic gist. We can see they gave us an equation for the best fit line as y equals 4/5 x. Notice there is not a y-intercept because the y-intercept is just 0, 0. So we don't see a b in that equation. It just looks like a regular rate problem. But it just means our intercept, our b, would be just plus 0. So here's our plan. We're going to find y when x is equal to 38 by just plugging it right into the formula. Y equals 4/5 x. So hit pause so you can jot this down. It's super short and we'll jump right in. Okay, for this plan, we already have our equation. It's given to us. We want to find what the water flow is when 38 minutes have passed. So our goal for this one is just to evaluate the expression. Y equals 4/5 x when x equals 38. So that's what we're going to do. We're just going to substitute 4/5 times 38. I am going to put it over 1 so we can solve that out. Bottom part is pretty easy. It's just 5. I'm going to do the math for the first top part. 8 times 4 is 32. 4 times 3 is 12. 12 plus 3 is 15. So 152 over 5. Let's simplify that part out. 152 divided by 5. 3. I get a 2 here. I'm going to put a 0. And 5 goes into 24 times. So y is equal to 30.4 What are my units? Gallons. So there's my answer. Let's put this as a full sentence. We approximate 30.4 gallons of water flowing after 38 minutes. And done. Hit pause so you can jot this one down into your notes. And Math Marvels, I hope you see how helpful this is. When we have a line of best fit, we can use an equation and use that equation to create an approximation. Now, some of you may have asked earlier, why isn't our line written in y equals mx plus b form? It just so happens it is. It's just that our b is equal to 0. So instead of saying 4/5 x plus 0, we just left it as 4/5 x. That's it for today, and let's get some practice.